Hello, in this lecture we will answer on two questions. The first question is to find out the diameter of this orange circle, and the second question is to find out the size of this angle theta. Okay, so we'll start with the first question. Here we have three semicircles in the drawing. The biggest semicircle consists of two small semicircles and the orange circle, and we want to find out the diameter of this orange circle. We also know that the diameter of this semicircle is equal to 10 units, therefore its radius is equal to 5 units. The diameter of this semicircle is equal to 20 units, therefore the radius of this semicircle is equal to 10 units. And we also know that the diameter of the biggest semicircle is equal to 10 plus 20 units, that is 30 units. Therefore, the radius of this semicircle, of the biggest semicircle, is equal to 15 units. So, we will define the radius of the orange circle as R. So write it down. The radius of the orange circle is defined as R. And the center of the orange circle is defined as point C, so I'll write it down. We define the centers of the semicircles. Here we define the center of the smallest semicircle, this semicircle, as point X. We define the center of the biggest semicircle, this semicircle, as point Y. And we will define the center of this semicircle as point Z. In the next step, we will join together the centers of the semicircles with the center of the orange circle that is located at this point, point C. Okay? We will find out the length of the line segments that we created here. But first of all, I will present to you two new rules in relation to two circles that are touching each other at one point. The first rule, we have actually two types of tendency between two circles that are touching each other at one point. The first type of tendency is the external lunge. In the external lunge, the two circles are touching each other externally. In this drawing, those two circles are touching each other externally at this point. This is the point of tendency. And we also know that the center of the small circle is at point M, this point. The radius of the small circle is equal to small r, while the center of the big circle is at this point, point O, and the radius of the big circle is equal to capital R. And actually, the distance between the centers of the two circles, that is actually line segment MO, it is equal to the sum of the lengths of their radii. The radius of the small circle equals to small r, the radius of the big circle equals to capital R, and the sum of the lengths of their radii equal to capital R plus small r. So whenever you have an external lunge between two circles, that is to say when the two circles are touching each other externally, then the distance between their centers will be equal to the sum of the lengths of their radii. In this case, it is equal to capital R plus small r. So the external lunge is the first type of tendency between two circles, and we have also another type of tendency between two circles, that is actually the internal lunge. In this case, the two circles are touching each other internally at this point. This is the point of tendency between the two circles. And the distance between their centers, that is to say the length of line segment MO, will be equal to the difference between the lengths of their radii. In this case, OM or MO equals to capital R minus small r. So, in conclusion, we have two types of tendency between two circles. The first type is the external lunge. When the two circles are touching each other externally, then the distance between their centers will be equal to the sum of the lengths of their radii. In this case, it will be equal to capital R plus small r. And the second type of tendency between two circles is the internal lunge, when they are touching each other internally, and the distance between their centers will be equal to capital R minus small r, or it will be equal in general to the difference between the lengths of their radii. In this case, it will be equal to capital R minus small r. So we will use those two rules in order to find out the length of the line segments in this drawing. Okay, so what is the length of line segment CX? Actually, C is the center of the orange circle, that its radius is defined as R according to our definition. X is the radius of the smallest semicircle, that its radius is equal to 5 units, and those two circle and semicircle have an external notch between them at this point, that is to say they are touching each other externally at this point. And when you have two circles that are touching each other externally, then the distance between their centers will be equal to the sum of the lengths of the eye. That is to say, it will be equal to the length of the radius of the orange circle, that is R, plus the length of the radius of this smallest semicircle, that is 5. And the sum of the lengths of the eye will be equal to 5 plus R. In conclusion, we found out that Cx equals to 5 plus R. Likewise, we will find out the length of line segment Cy. C is the center of the orange circle with radius R. Y is the center of the biggest semicircle with radius 15. The orange circle and the biggest semicircle are touching each other internally at this point. This is the point of tendency between the orange circle and the biggest semicircle. Whenever you have an internal length between two circles, then the distance between their centers will be equal to the difference between the lengths of the radii. The radius of the biggest semicircle equals to 15 units, the radius of the orange circle equals to R, and the difference between the radii will be equal to 15 minus R. So, in conclusion, we found out that Cy equals to 15 minus R. Likewise, we will find out the length of line segment CZ. I repeat again, C is the center of the orange circle with radius R. Z is the center of this semicircle with radius 10. The orange circle and this semicircle have an external notch between them at this point, that is to say they are touching each other externally at this point. And whenever you have an external notch between two circles, then the distance between their centers will be equal to the sum of the lengths of their radii. That is to say, it will be equal to the radius of this semicircle, that is 10, plus the radius of the orange circle, that is R. So in conclusion, we found out that line segment CZ equals to 10 plus R. Likewise, we will find out the length of line segment XY. X is the center of the smallest semicircle with radius 5. Y is the center of the biggest semicircle with radius 15. The smallest semicircle and the biggest semicircle have an internal notch between them at this point, that is to say they are touching each other internally at this point. This is the point of tendency, and whenever you have two circles that have an internal notch between them, then the distance between their centers will be equal to the difference between the lengths of their radii. In this case, it will be equal to the radius of the biggest semicircle, that is 15, minus the radius of the smallest semicircle, that is 5, and the difference between those two of the I is 15 minus 5 is 10. So we found out that xy equals to 10 units. Likewise, we will find out the length of line segment xz. Here x is the center of the smallest semicircle with radius 5. Z is the center of this semicircle with radius 10. Those two semicircles have an external length between them, and this point P, that is to say they are touching each other externally at point P. And whenever we have two circles that have an external length between them, then the distance between their centers will be equal to the sum of the lengths of the radii. The radius of the smallest semicircle is 5 units, the radius of this semicircle is 10 units, and the sum of the length of the radii is 5 plus 10, it is 15. In conclusion, we found out that xz equals to 15 units. So actually found out all the lengths of the line segments in the drawing. In the next step, I will present to you a new law. It is the law of cosines. The law of cosines is true in any triangle. So here we have triangle ABC that could be any triangle. This is triangle ABC. We know that side AB of triangle ABC equals to A units in its length. Side BC of triangle ABC equals to B units in its length. And side AC of this triangle equals to C units in its length. And we also know that the angle between side AB and side BC is theta. So according to the law of cosines, C squared equals to A squared plus B squared minus 2 times AB times cosine theta. And this is true in any triangle. Actually, the Pythagoras theorem is a special case of the law of cosines when angle theta is equal to 90 degrees. When angle theta is equal to 90 degrees, then we are talking on a right triangle. And so if theta equals to 90 degrees, then cosine 90 degrees is equal to 0. So here we will get that 2 times AB times cosine 90 degrees equals to 0, because anything that you multiply by 0 will be 0 and will be equal to 0. And so this is 2 minus 2 times AB cosine theta will be equal to 0. And we left with the Pythagoras theorem. C squared equals to A squared plus B squared, that is to say the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in conclusion, the Pythagoras theorem is a special case of the law of cosines when angle theta is equal to 90 degrees. Okay? So we'll copy triangle XCY in a new page, and we will implement the law of cosines in this triangle, triangle XCY. So this is triangle CXY. This is angle theta. We have already found out that Cx is equal to 5 plus r. Xy is equal to 10 units. Cy is equal to 15 minus r. So now we can implement the law of cosines in this triangle, triangle CXY. According to the law of cosines, we will get that Cy squared is equal to xc squared plus xy squared minus 2 times cx times xy times cosine theta this will be equation number 1. We will substitute cy in equation number 1 by 15 minus r. We will substitute xc by 5 plus r. We will substitute xy by 10 in equation number 1. So we'll do it now and we will get that according to equation number 1, cy squared, cy is equal to 15 minus r. As you can see from the drawing, therefore cy squared equals to 15 minus r squared, and it is equal to xc squared. xc equals to 5 plus r, and therefore xc squared will be equal to 5 plus r squared plus xy squared. xy equals to 10. xy squared is 10 squared. 10 squared is 100. Minus 2 times cx is 5 plus r. xy is 10 times cosine theta. Here we will open the brackets on both sides of equation number 1, and we will get that according to equation number 1, 15 minus r squared equals to 15 squared, that is 225, plus r squared minus 2 times 15 times r, that is equal to 5 plus r squared. 5 plus r squared equals to 5 squared, that is 25, plus r squared plus 2 times 5r, it is actually 10r, plus 100, minus 2 times 20 is minus 20, minus 2 times 10 is minus 20, 5 plus r times cosine theta. Here we have r squared on both sides of equation number 1, so r squared will get cancelled. So in this side of the equation, what is left after we cancelled r squared? What is left? It is actually 225 minus 2 times 15r is minus 30r, and it is equal to here we have 25 plus 100 is 125 plus 10r minus 20 times 5 plus r times cosine theta. We will subtract 125 from this equation, and we will get that 225 minus 125 is 100. We will subtract 10r from this equation, equation number 1. And we will get that minus 30r minus 10r is minus 40r equals to minus 20 times 5 plus r times cosine theta. Now we will multiply equation number 1 by minus 1. And we will get that according to equation number 1, minus 40r times minus r is 40r. Minus 1 times 100 is minus 100. And it is equal to minus 20 times minus 1 is plus 20 times 5 plus r times cosine theta. Here we will divide equation number 1 by 20 times 5 plus r. And we will get that according to equation number 1, cosine theta is equal to 40r minus 100 over 20 times 5 plus r. Here we will divide both the numerator and the denominator of equation of this side of equation number 1 by 20, and we will get that 40r over 20 is 2r, minus 100 over 20 is minus 5. Here 20 over 20 is 1, so in the denominator we left only with 5 plus r. So in conclusion, we found out that cosine theta, according to equation number 1, is equal to 2r minus 5 over 5 plus r. I'll repeat again. According to equation number 1, we found out that cosine theta equals to 2r minus 5 over 5 plus r. In the next step, we will implement the law of cosines in triangle XCZ. So I will copy triangle XCZ in this new page, and we will implement the law of cosines in this triangle XCZ. We have already found out that xc equals to 5 plus r, and we also found out that xz equals to 15 units, and cz equals to 10 plus r, and this is angle theta, of course. So we will implement the law of cosines in this triangle, triangle CXZ. This will be equation number 2. According to equation number 2, we will get that CZ squared equals to XC squared plus XZ squared minus 2 times Cx times Xz times cosine theta. In the next step, we will substitute CZ by 10 plus R. We will substitute in equation number 2. We will substitute XC by 5 plus R. And we will substitute XZ by 15. In equation number 2. So we will do it now. We will get that according to equation number 2. CZ equals to 10 plus R. Therefore, CZ square will be equal to 10 plus R square, and it is equal to XC square. XC is 5 plus R, so XC square will be equal to 5 plus R square, plus XZ. XZ is 15, therefore XZ square will be equal to 15 square, minus 2 times Cx is 5 plus R, times Xz, it is 15, times cosine theta. So here we will open the brackets on both sides of equation number 2, and we will get that according to equation number 2, 10 plus R square, it is equal to 10 square, that is 100, plus R square, plus 2 times 10R, that is 20R, and it is equal to 5 plus R square. 5 plus R square is equal to 5 square, that is 25, plus R square, plus 2 times 5R, that is 10R, plus 15 square, that is 225, minus 2 times 15 is minus 30, times 5 plus R, times cosine theta. So in this equation, equation number 2, we have R square on both sides of equation number 2, so R square will get cancelled, and we're left with 100 plus 20R. On this side of the equation, 100 plus 20R is equal to 225 plus 25 is 250, plus 10R, minus 30 times 5 plus R times cosine theta. We will subtract 250 from this equation, equation number 2, and 100 minus 250 is minus 150. We will subtract 10R from this equation, equation number 2, and we get that 20R minus 10R is 10R plus 10R, and it is equal to minus 30 times 5 plus R times cosine theta. Here we will multiply equation number 2 by minus 1, and we will get that according to equation number 2, minus 150 times minus 1 is 150. 10R times minus 1 is minus 10R. Minus 30 times minus 1 is plus 30. So it is 30 times 5 plus R times cosine theta. Here we will divide equation number 2 by 30 times 5 plus R, and we will get that according to equation number 2, cosine theta equals to 150 minus 10R over 30 times 5 plus R. Here we will divide both the numerator and the denominator of this side of equation number 2 by 10. and we will get that 150 over 10 is 15, minus 10r over 10 is minus r, 30 over 10 is 3, so in the denominator we have 3 times 5 plus r. So in conclusion, we found out that according to equation number 2, cosine theta is equal to 15 minus r over 3 times 5 plus r, but according to equation number 1, we have already found out that cosine theta is equal to 2r minus 5 over 5 plus r. In the next step, we will create equation number 3 that states that cosine theta according to equation number 1 must be equal to cosine theta according to equation number 2. So according to equation number 3, we will get that cosine theta according to equation number 1, that is 2r minus 5 over 5 plus r, must be equal to cosine theta according to equation number 2, that is actually 15 minus r over 3 times 5 plus r. Here we will multiply equation number 3 by 5 plus r. Therefore, 5 plus r in the denominator will get cancelled. And we will multiply equation number 3 by 3. And we will get that according to equation number 3, 3 times 2r minus 5 equals to 15 minus r. Here we will open the brackets of this side of equation number 3, and we get that 3 times 2r is 6r, 3 times minus 5 is minus 15, and it is equal to 15 minus r. Here we will add to this equation number 3r, and we will also add 15, and we will get that according to equation number 3, 6r plus r is 7r, and 7r equals to 15 plus 15, that is 30. Here we'll divide equation number 3 by 7, and we get that according to equation number 3, r, the radius of the orange circle, equals to 30 over 7 units. But we are looking for the diameter of the semicircle. So the diameter of the semicircle, the diameter of the orange circle, the diameter of this orange circle is equal, we know that the diameter is twice as large as the radius, so it is equal to 2r. That is to say, it equals to 2 times r is 30 over 7. So 2 times 30 is 60, so it is 60 over 7 units. So the diameter of the orange circle is equal to either 60 over 7 units, or in terms of numbers, it equals to 8.5714 units. I'll repeat again. the diameter of the orange circle, the diameter of this orange circle is equal to either 60 over 7 units, or in terms of numbers, it equals to 8.5714 units. In the next step, I will summarize the lecture. Actually, we wanted to find out the diameter of this orange circle. And in the drawing we have 3 semicircles. The biggest semicircle consists of 2 small semicircles and also the orange circle. The radius of the biggest semicircle is equal to 15 units. The radius of this semicircle is equal to 10 units. The radius of this semicircle is equal to 5 units, and we want to find out the diameter of this orange circle. So we defined the diameter of this orange circle as R, and we defined the center of this orange circle as point at C. So this point is point C. We defined the center of this semicircle, the smallest semicircle, as X. We defined the center of the biggest semicircle, this semicircle, as Y. And we defined the center of this semicircle as Z. Then we join together all the centers of the semicircles with the center of the orange circle that is at point C, this point. And in order to find out the lengths of the line segments that we created here, I presented to you 2 new rules. Actually, when 2 circles are touching each other at one point, there are 2 types of tangency between 2 circles. The first type of tendency between 2 circles is the external lunge. When the 2 circles are touching each other externally, like in this drawing, those 2 circles are touching each other externally at this point. Then the distance between their centers will be equal to the sum of the lengths of their radii. That is to say, it will be equal, in this case, to capital R plus small r. Okay, so this is the first type of tendency. I'll repeat again, whenever 2 circles are touching each other externally, that is the external lunge, then the distance between their centers will be equal to the sum of the lengths of their radii. And we also have the second type of tendency, is when the circles are touching each other internally. This is the internal lunge. And in this case, the distance between their centers, that is to say, the length of line segment MO, will be equal to the difference between the lengths of their radii. In this case, it will be equal to capital R minus small r. Okay, so we used those two new rules in order to find out the values of the line segments in this drawing. What is the value of line segment CX? C is the center of the orange circle that its radius is equal to R. X is the center of the smallest semicircle that its radius is equal to 5 units. And the orange circle and this semicircle have an external lunge between them at this point. That is to say, they are touching each other externally. At this point, this is the point of tendency between the orange circle and the semicircle. And whenever we have an external lunge between two circles, then the distance between their centers, that is to say Cx, will be equal to the sum of the lengths of the radii. The radius of this orange circle is equal to r. The radius of this smallest semicircle is equal to 5. And the sum of the lengths of the radii is 5 plus x. 5 plus r. Okay, so actually found out that the length of line segment Cx equals to 5 plus r. That is the sum of the lengths of the radii of the orange circle and the smallest semicircle. Likewise, we found out the length of line segment CY. C is the center of the orange circle with radius r. Y is the center of the biggest semicircle with radius 15. The orange circle and the biggest semicircle have an internal notch between them at this point, that is to say they are touching each other internally at this point, and whenever two circles are touching each other internally, then the distance between their centers will be equal to the difference between the lengths of their radii. In this case, it will be equal to the radius of the biggest circle, that is 15, minus the radius of the orange circle, that is r. That is to say Cy equals to 15 minus r. Okay? Likewise, we calculated the length of line segment CZ. Again, C is the center of the orange circle with radius r. Z is the center of this semicircle with radius 10. And those circle and the semicircle have an external notch between them at this point, that is to say they are touching each other externally at this point. This is the point of tendency between the circle and the semicircle, and whenever we have an external notch between two circles, then the distance between their centers will be equal to the sum of the length of the radii, that is to say it will be equal to the radius of this circle, that is 10, plus the radius of this circle, that is r, that is to say Cz will be equal to 10 plus r. Okay? Then we found out the length of line segment xy. X is the center of this semicircle with radius 5. Y is the center of the biggest semicircle with radius 15. The smallest semicircle and the biggest semicircle have an internal notch between them at this point. That is to say they are touching each other internally at this point. This is the point of tendency between the two semicircles. And whenever you have two circles that are touching each other internally, then the distance between their centers will be equal to the difference between the lengths of their radii. The length of the radius of the biggest circle is 15 units, the length of the radius of this semicircle is 5 units, and the difference between their radii is 15 minus 5, that is to say 10. So we found out that xy, line segment xy equals to 10 units. Likewise, we calculated the value of line segment xz. Again, x is the center of this smallest semicircle with radius 5. Z is the center of this semicircle with radius 10. Those two semicircles have an external notch between them at this point, that is to say they are touching each other externally at point P. Point P is the point of tendency between the two semicircles, and whenever you have two circles that have an external notch between them, then the distance between their centers will be equal to the sum of the lengths of their radii. In this case, it will be equal to the radius of this semicircle, that is 5 units, plus the radius of this semicircle, that is 10 units. 5 plus 10 is 15. So we found out that xz equals to 15 units. In the next step, I presented to you the law of sines. The law of sines is true in any triangle. So actually, this is triangle ABC that could be any triangle. The length of side AB is A units. The length of side BC is B units. The length of side AC is equal to C units. And the angle between side AB and side CB is theta. So according to the law of cosines, C squared equals to A squared plus B squared minus 2 times AB times cosine theta. And this equation is true in any triangle. And I also mentioned that the Pythagoras theorem is a special case of the law of cosines. So the law of cosines is the general law that is applied for all the triangles in the world, and the special case is the Pythagoras theorem that it is true only for right triangles. So in the Pythagoras theorem we know that theta equals to 90 degrees. So if theta equals to 90 degrees, then triangle ABC, it is a right triangle. And so here theta equals to 90 degrees, therefore cosine 90 degrees is 0. 0 times 2AB is 0. So this expression minus 2 times AB cosine theta is 0. And we will get the Pythagoras theorem, C squared equals to A squared plus B squared. That is to say, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So you saw that the Pythagoras theorem is a special case of the law of cosines when theta equals to 90 degrees and we have a right triangle, and you saw that we got the Pythagoras theorem, that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, C squared equals to A squared plus B squared. So I copied triangle XCY in a new page and we implemented the law of cosines in this triangle XCY. So this is triangle XCY. We have already found out that X equals to 5 plus R, CY equals to 15 minus R, and XY equals to 10 units. And angle between CX and XY is theta. Then according to the law of cosines, we get that CY squared will be equal to CX squared plus XY squared minus 2 times CX times XY times cosine theta. Then this is equation number 1. Then we substituted CY by 15 minus R, we substituted CX by 5 plus R, and we substituted XY by 10 in equation number 1, of course, and we got that 15 minus R squared equals to 5 plus R squared plus 10 squared, that is 100, minus 2 times 5 plus R times 10 times cosine theta. We open the brackets on both sides of equation number 1 and we got that 15 minus R squared equals to 15 squared, that is 225 plus R squared minus 2 times 15 times R, and it is equal to 5 plus R squared. 5 plus R squared equals to 5 squared plus R squared plus 2 times 5R, that is 10R, plus 100 minus 2 times 10 is minus 20 times 5 plus R cosine theta. Then actually here we have R squared on both sides of equation number 1, so R squared will get cancelled. What is left from equation number 1 after we cancelled R squared? What is left, it is in this side of the equation number 1 we have 225 minus 30R, because 2 times 15R is 30. And in the other side of the equation we have 25 plus 100 is 125 plus 10R minus 20 times 5r times cosine theta. We subtracted 125 from this equation number 1. 225 minus 125 is 100. We also subtracted 10r from this equation number 1, and we got that minus 30r minus 10r is minus 40r. So in conclusion, we found out that in this side of equation number 1 we have 100 minus 40r, and on the other side of equation number 1 we have minus 20 times 5 plus r times cosine theta. We multiplied the equation number 1 by minus 1, and we got that minus 1 times minus 40r is 40r. 100 times minus 1 is minus 100, and minus 20 times minus 1 is plus 20. So in conclusion, we got that 40r minus 100 equals to 20 times 5 plus r times cosine theta. We divided the equation number 1 by 20 times 5 plus r, and we got that according to equation number 1, cosine theta equals to 40r minus 100 over 20 times 5 plus r. Here we divided both the numerator and the denominator on this side of equation number 1 by 20. So here 40r over 20 is 2r, and minus 100 over 20 is minus 5. And here 20 over 20 is 1, so in the denominator we left with 5 plus r. So in conclusion, we found out that according to equation number 1, cosine theta equals to 2r minus 5 over 5 plus r. Then I copied triangle CXZ in this new page, and we implemented the law of cosines in this triangle XCZ, CXZ. We already found out that CX equals to 5 plus x, CZ is equal to 10 plus r, and XZ equals to 15 units. So according to the law of cosines, we will get that CZ square equals to CX square plus XZ square minus 2 times CX times XZ times cosine theta. This is equation number 2. In the next step, we substituted XC by 5 plus r. We substituted CZ by 10 plus r in equation number 2, and we substituted XZ by 15. And we got that according to equation number 2, 10 plus r square equals to 5 plus r square plus 15 square minus 2 times 5 plus r times 15 times cosine theta. We open the brackets on both sides of equation number 2, and we got that 10 plus r square equals to 10 squared, that is 100, plus r square minus 2 times 10r is 20r, equals to 5 plus r square. 5 plus r square equals to 5 squared, that is 25, plus r square, plus 2 times 5r, that is 10r, plus 15 square. 15 square is 225, minus 2 times 15 is minus 30, so this expression equals to minus 30 times 5 plus r times cosine theta. Here we have r square on both sides of equation number 1, so r square will get cancelled. So what is left from equation number 1 after we cancelled r square? What is left is that in this side of equation number 2, we have r plus 20r, 100 plus 20r, and in the other side of equation number 2, we have 25 plus 225 is 250, plus 10r, minus 30 times 5 plus r times cosine theta. Here we subtracted 250 from equation number 2. 100 minus 250 is minus 150. We subtracted also 10r from this equation number 2. So 20r minus 10r is 10r. And here we have minus 30 times 5 plus r times cosine theta. We multiplied the equation number 2 by minus 1, and we got that minus 1 times minus 150 is plus 150, and 10r times minus 1 is minus 10r. minus 30 times minus 1 is plus 30. So in conclusion, we got that 150 minus 10r equals to 30 times 5 plus r times cosine theta. We divided the equation number 1 by 30 times 5 plus r, and we got that according to equation number 2, cosine theta equals to 150 minus 10r over 30 times 5 plus r. Here we divided both the numerator and the denominator of equation number 2 by 10, and we got that 150 over 10 is 15, minus 10r over 10 is minus r, and we have also here 30 over 10. 30 over 10 is 3. So in conclusion, we got that according to equation number 2, cosine theta equals to 15 minus r over 3 times 5 plus r. But according to equation number 1, we have already found out that cosine theta equals to 2r minus 5 over 5 plus r. Then we created equation number 3 that states that cosine theta according to equation number 1 must be equal to cosine theta according to equation number 2. So according to equation number 3, we will have that cosine theta according to equation number 1, that is 2r minus 5 over 5 plus r, must be equal to cosine theta according to equation number 2, that is actually 15 minus r over 3 times 5 plus r. Here we multiply the equation number 3 by 5 plus r, so 5 plus r in the denominator will get cancelled. Then we multiply the equation number 3 by 3, and we got that 3 times 2r minus 5 equals to 15 minus r. We open the brackets on this side of equation number 3, and we got that 3 times 2r equals to 6r. 3 times minus 5 is minus 15. So in conclusion, we found out that according to equation number 3, 6r minus 15 equals to 15 minus r. We added to equation number 3 this equation r, and also we added 15. So 6r plus r is 7r, and 15 plus 15 is 30. So in conclusion, we got that according to equation number 3, 7r equals to 30. We divided equation number 3 by 7, and we got that the radius of the semicircle r equals to 30 over 7 units. And therefore the diameter of the orange circle is twice as large as the radius. That is to say, it will be equal 2 times the radius, that is 30 over 7. 2 times 30 over 7 is 60 over 7. That is the diameter. So we found out that the diameter of this orange circle is equal to either 60 over 7 units, or in terms of numbers, it equals to 8.5714 units. So we finished with the first question. In the next step, we will solve the second question. Here in the drawing we have a quarter circle. In this quarter circle we have square ABCO. We also know that angle A and B is a right angle, it is equal to 90 degrees. And we also know that angle BQC is equal to theta, and theta is the angle that we are looking for. And we will find out the value of theta by doing the following construction. Actually, we will extend line segment MA by a straight line, and we will also extend line segment QO by straight line until they intersect with each other. Okay? And we will define the intersection point between the extended line segment MA and the extended line segment QO as point N. In the next step, we will complete the quarter circle that we have in the drawing to a semicircle. Okay? So we created here a semicircle from the quarter circle, and we have here angle NMQ that is equal to 90 degrees. That is to say, the peripheral angle NMQ is equal to 90 degrees. And in relation to peripheral angle that is equal to 90 degrees, we have a new rule. We'll present rule number 1. According to rule number 1, any peripheral angle that is equal to 90 degrees must rest on the diameter. I'll read rule number 1 again. According to rule number 1, any peripheral angle that is equal to 90 degrees must rest on the diameter. So here we have the peripheral angle NMQ that is equal to 90 degrees. Therefore, according to rule number 1, this peripheral angle that is equal to 90 degrees must rest on the diameter. That is to say, angle NMQ rests on the diameter. Angle NMQ rests on NQ. So NQ is the diameter of the semicircle according to rule number 1. From rule number 1, we will conclude that NQ is the diameter of the semicircle. According to rule number 1, of course, NQ is the diameter. But here, because of the fact that this is a quarter circle, then QO must be equal to the radius of the quarter circle. We'll define the radius of the quarter circle as capital R. Therefore, QO equals to capital R. And the diameter of any circle or semicircle is twice as large as the radius. Therefore, NQ itself will be equal to 2R. NQ is equal to 2R. And what is the value of line segment NO? From the drawing, it is very easy to see that NO equals to NQ minus QO. That is to say, NO equals to NQ, that is 2R, minus QO, that is R. 2R minus R is R, so we found out that NO, it is equal to the radius of the semicircle. Of course, the radius of the quarter circle and the semicircle is the same radius. And the radius of the circle itself is also equals to capital R, of course. And so in the next step, we will focus on the right triangle, triangle NMQ. In the right triangle, triangle NMQ, we know that the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles in any triangle is equal to 180 degrees. So which angles we have in triangle NMQ? We have here 90 degrees. We have also here angle theta, and we have also angle Q and M. Q and M. In total, the sum of those three angles must be equal to 180 degrees according to the rule that the sum of the angles in any triangle is equal to 180 degrees. So here we will subtract 90 degrees from this equation, and we will get that theta plus angle QNM is equal to 180 degrees minus 90 degrees. It is 90 degrees. We'll subtract theta from this equation, and we get that angle QNM, the angle that we are looking for, is equal to 90 degrees minus theta. Okay, angle QNM equals to 90 degrees minus theta. So here, you write down that angle QNM, the missing angle, equals to 90 degrees minus theta. And we also know that all the angles inside the square are right angles, therefore all the angles inside square ABCO, they are equal to 90 degrees, so we can draw inside square ABCO 4 right angles. Okay, and we know that NQ is the diameter of the semicircle. NQ is the diameter of the semicircle. It must be a straight line. So if you write down that NQ is the diameter, it must be a straight line. I'll write it down. NQ is the diameter, must be a straight line, is a straight line. Line segment NQ is a straight line. NQ is a straight line. We actually have also rule number 2 that is related to straight line. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. I write it down. The sum of the angles on one side of a straight line is equal to 180 degrees. I repeat again, according to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. So here, if we focus on the upper side of the straight line NQ at point O, this point Then the sum of the angles here must be equal to 180 degrees according to rule number 2. Okay. So each angles we have on the upper side of NQ at point O. We have here one angle that is equal to 90 degrees, and we also have angle AON. This angle, in total the sum of those two angles must be equal to 180 degrees according to rule number 2. I'll repeat again. On the upper side of the straight line NQ at point O, the sum of the angles must be equal to 180 degrees according to rule number 2. So at point O we have one angle that is a right angle, and we also have the angle AON. In total the sum of those two angles must be equal to 180 degrees according to rule number 2. We will subtract 90 degrees from this equation, and we will get that the missing angle AON is equal to 180 degrees minus 90 degrees. It is equal to 90 degrees. It is a right angle. So you can write here that the missing angle AON is a right angle. It is equal to 90 degrees. Likewise, if we focus on the upper side of the straight line NQ at point C, then the sum of the angles on the upper side of NQ at point C must be equal to 180 degrees according to rule number 2. So which angles we have on the upper side of NQ at point C? We have here 90 degrees. And we have also this angle that is angle BCQ. In total the sum of those two angles must be equal to 180 degrees according to rule number 2. I'll repeat again. If we focus on the upper side of the straight line NQ at point C, then the sum of the angles there must be equal to 180 degrees. Which angles we have at point C? We have 90 degrees, and we have also angle BCQ. So according to rule number 2, the sum of those two angles in total must be equal to 180 degrees. We will subtract 90 degrees from this equation, and we will get that the missing angle BCQ will be equal to 180 degrees minus 90 degrees. It is 90 degrees. So we found out that the missing angle BCQ is a right angle. This angle equals to 90 degrees. So we will continue to focus on the right triangle BCQ. In the right triangle BCQ, we know that the sum of the angles must be equal to 180 degrees. So which angles we have inside triangle BCQ? We have one angle that is equal to 90 degrees. We also have one angle that is equal to theta. And we also have this angle that is actually angle CBQ. In total, the sum of those three angles must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. Okay, in the right triangle BCQ, the sum of the angles equals to 180 degrees. That is to say 90 degrees plus angle theta plus the missing angle that is angle CBQ. In total, they must be equal to 180 degrees. We will subtract 90 degrees from this equation, and we will get that theta plus angle CBQ must be equal to 180 degrees minus 90 degrees. It is 90 degrees. Here we will subtract theta from this equation, and we get that the missing angle CBQ is equal to 90 degrees minus theta. Okay, angle CBQ equals to 90 degrees minus theta. So you can write here that the missing angle CBQ equals to 90 degrees minus theta. Likewise, in the right triangle AON, the sum of the angles must be equal to 180 degrees. So which angles we have in the right triangle AON? We have here right angle, one angle that is equal to 90 degrees. We have here also one angle that is equal to 90 degrees minus theta. And we have also this angle that is actually angle OAN. In total, the sum of those three angles must be equal to 180 degrees. Okay, the sum of the angles in the right triangle AON must be equal to 180 degrees. So one angle is 90 degrees, the other angle is 90 degrees minus theta, and the third angle is angle OAN. In total, the sum of those three angles must be equal to 180 degrees. We'll subtract 90, here we have 90 degrees plus 90 degrees is 180 degrees. So we have 180 degrees on both sides of the equation, so 180 degrees will get cancelled. And we're left only with minus theta plus angle OAN equals to 0. Minus theta plus angle OAN is equal to 0. Here we will add theta to this equation and we will get that the missing angle OAN is equal to theta. We found out that the missing angle OAN equals to theta. So this angle is equal to theta. So actually we found out that all the angles of the right triangle AON can go into all the angles of the right triangle BCQ. Why? Because both those two triangles have this angle theta, both those two triangles have angle that is 90 degrees minus theta, and both those two triangles have right angles. Okay, so actually we found out that the right triangle AON is similar to the right triangle BCQ. The right triangle AON is similar, this is the sign of similar, to the right triangle BCQ according to angle similarity rule. Okay, and from the fact that those two right triangles are similar to each other, we will conclude that CQ over AO is equal to BC over ON. I will repeat again. From the fact that those two triangles are similar to each other, we will conclude that CQ over AO equals to BC over ON. Okay? So, what is the value of line segment CQ? Here, CQ, this line segment CQ is equal to OQ minus OC. I'll repeat again. CQ equals to OQ minus OC. So CQ equals to OQ, that is R, minus OC. We will define OC as A. So if OC equals to A, then all the other sides of square ABCO will be also equal to A. So in conclusion, we found out that CQ is equal to R minus A. So we will substitute R minus A in equation, we will substitute CQ in equation number 1 by R minus A, and we get that according to equation number 1, CQ is equal to R minus A over AO. AO is also equals to A, and according to equation number 1, it is equal to BC. BC is also equals to A over ON. We have already found out that ON equals to R. So in conclusion, we found out that according to equation number 1, R minus A over A equals to A over R. We'll split this expression to two expressions. R minus A over A equals to R over A minus A over A, that is minus 1, and it is equal to A over R, but A over R equals to 1 over R over A. We will focus on the right triangle, triangle AON. In the right triangle, triangle AON, in this right triangle, triangle AON, we know that tangent theta equals to R over A. Again, tangent theta equals to R over A. So we can substitute R over A in equation number 1 by tangent theta. We'll do it now, and we'll get that R over A is tangent theta according to this equation. Minus 1 equals to 1 over R over A, it is also tangent theta. So according to equation number 1, we found out that tangent theta minus 1 equals to 1 over tangent theta. We will multiply equation number 1 by tangent theta, and we will get that according to equation number 1, tangent theta times tangent theta is tangent square theta. Tangent theta times minus 1 is minus tangent theta. It is equal to 1. Here we subtract from equation number 1, and we get that according to equation number 1, tangent square theta minus tangent theta minus 1 equals to 0. So we have here a quadratic equation, and the missing variable in this quadratic equation is tangent theta. Actually, the general formula for quadratic equation is ax squared plus bx plus c equals to 0. If a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to the following formula for x. X, it is actually equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. And in our specific quadratic equation, we know that a is equal to 1 B is equal to minus 1 and C is also equal to minus 1, and the missing variable that we are looking for, that is to say x is equal to tangent theta. So in order to find the value of tangent theta, we will put the data inside the equation for x in order to find out the value of tangent theta, the values of tangent theta. So x is equal to tangent theta. Tangent theta is equals to minus b. B equals to minus 1. So minus b is minus 1, that is plus 1, plus minus square root of b squared. B squared is minus 1 squared, that is 1, plus minus 4 times a is 1, times c is minus 1, over 2a. A is 1, so 2 times 1 is 2. So we found out that tangent theta is equal to 1 plus minus square root of minus 4 times minus 1 is 4, and 4 plus 1 is 5, over 2. So actually, tangent theta we will have two solutions for tangent theta. The first solution is tangent theta equals to 1 plus square root of 5 over 2. And the second solution for tangent theta is that tangent theta equals to 1 minus square root of 5 over 2. And we'll focus on the second solution. Tangent theta equals to 1 minus square root of 5 over 2. It is a negative solution, it is less than 0. But here we have right triangle. Triangle NMQ is a right triangle. And we have this angle that is equal to 90 degrees minus theta inside the right triangle. Therefore, it is absolutely a positive angle. That is to say, it is greater than 0. Because it is 1 out of 3 angles in the right triangle, therefore it must be a positive. So we can write down that 90 degrees minus theta is a positive, is greater than 0. We will add theta to this equation and we will get that 90 degrees is greater than theta. So theta is less than 90 degrees from one side, but from the other side you can see that this is angle theta. From the drawing you can see that angle theta is a positive angle, so theta is greater than 0. From the other side is greater than 0. From one side angle theta is less than 90 degrees, and from the other side angle theta is greater than 0. And in this range of angles, tangent itself is a positive number. Tangent theta will be positive in this region of angles from 0 to 90 degrees. So tangent theta will be positive number greater than 0. But according to what we have already found out, that the second solution is a negative. In the second solution, tangent theta is less than 0. While here we found out that tangent theta must be a positive. So we have here a contradiction, so this solution is incorrect solution. We will cancel this solution and we will focus on the solution that tangent theta equals to 1 plus square root of 5 over 2. So if tangent theta equals to 1 plus square root of 5 over 2, then what is the value of theta itself? In order to find out the value of theta itself, we will operate the inverse function of tangents on the result. We will operate the inverse function of tangents on the result, that is 1 plus square root of 5 over 2, and we will get that the angle theta itself will be equal to 58.28 degrees. So we actually found out that the size of this angle theta equals to 58.28 degrees. Okay, in the next step I will summarize the lecture. Actually, we wanted to find out the value of angle theta this angle theta. We have here a quarter circle in this quarter circle we have square ABCO. We also know that this angle A and B is equal to 90 degrees. It is a right angle. And we have also angle BQC, that is theta, and we want to find out the value of the size of angle theta. So in order to find out the size of angle theta, we made a construction. We extended line segment MA by a straight line, and we extended also line segment QO by a straight line until they intersect with each other. At point N, we define the intersection point between extended line segment MA and the extended line segment QO as N. And then we completed the quarter circle to a semicircle. Actually, we have here a semicircle, and inside this semicircle we have the peripheral angle NMQ, that is a right angle. And in relation to a peripheral angle that is equal to 90 degrees, we have a rule, that is rule number 1. According to rule number 1, any peripheral angle that is equal to 90 degrees must rest on the diameter. That is to say, we have the peripheral angle NMQ that is equal to 90 degrees. Therefore, according to rule number 1, it must rest on the diameter. That is to say, and we know that angle NMQ rests on NQ. Therefore, according to rule number 1, NQ must be the diameter of the semicircle. So according to rule number 1, NQ is the diameter of the semicircle. According to rule number 1. So the diameter QN is twice as large as the radius. So here from the quarter circle, you can see that NO is the radius. We define the radius of the quarter circle as R. And the diameter is twice as large as the radius. So if the radius is R, then the diameter NQ will be equal to 2R. And what is the value of ON? From the drawing, you can see that ON equals to QN minus QO. ON equals to QN minus QO. QN equals to 2R, QO equals to R. So we found out that NO equals to 2R minus R, it is R. So we found out that QO or NO is the radius of the semicircle, and QO is also the radius of the semicircle, that is also equals to R. Okay? Then we focused on the right triangle MNO. On this right triangle, we know that the sum of the angles must be equal to 180 degrees. So which angles we have here? We have here 90 degrees, we have angle theta, and we have this angle. So actually, the angle that is equal to 90 degrees plus angle theta plus the third angle that is angle Q and O, in total they must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. We subtracted 90 degrees from this equation, and we got that angle theta plus angle Q and M must be equal to 90 degrees. We subtracted theta from this equation and found out that the missing angle Q and M equals to 90 degrees minus theta. So this angle, the missing angle Q and M equals to 90 degrees minus theta. And because of the fact that we found out that NQ is the diameter of the semicircle, it is absolutely a straight line. The diameter it must be a straight line. Okay, diameter must be a straight line. Therefore, NQ, that is the diameter, must be a straight line. NQ is a straight line. And we have rule number 2 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. So here, if we focus on the upper side of the straight line NQ at point O, then the sum of the angles at this point O must be equal to 180 degrees according to rule number 2. So which angles we have on the upper side of NQ at point O? We have here 90 degrees plus angle AON. In total, the sum of those two angles must be equal to 180 degrees. 90 degrees plus here 90 degrees plus the size of angle AON must be equal to 180 degrees according to rule number 2. Okay, we subtracted 90 degrees from this equation and we got that the missing angle AON equals to 90 degrees. So we found out that this angle AON equals to 90 degrees. Then we focused on the upper side of the straight line NQ at point C. On the upper side of NQ at point C, the sum of the angles must be equal to 180 degrees according to rule number 2. So which angles we have at point C? We have 90 degrees plus angle BCQ. At 90 degrees plus the size of angle BCQ, in total they must be equal to 180 degrees according to rule number 2. We subtracted 90 degrees from this equation and we found out that angle BCQ equals to 90 degrees. So this is also a right angle. Then we continue to focus on the right triangle BCQ. We know that in the right triangle BCQ, the sum of the angles must be equal to 180 degrees. So which angles we have here? We have here 90 degrees, we have angle theta and also angle CBQ. 90 degrees plus angle theta plus angle CBQ, in total they must be equal to 180 degrees. We subtracted 90 degrees from this equation and we get that angle theta plus angle CBQ will be equal to 180 degrees minus 90 degrees. It is 90 degrees. We subtract the theta from this equation and we got that the missing angle CBQ equals to 90 degrees minus theta. This angle equals to 90 degrees minus theta. Likewise, we know that in the right triangle AON, the sum of the angles must be equal to 180 degrees. So which angles we have here? We have 90 degrees. We have an angle that is equal to 90 degrees minus theta, and we have angle OAN. In total, the sum of those three angles must be equal to 180 degrees. 90 degrees plus the second angle that is 90 degrees minus theta plus the size of angle OAN. In total, they must be equal to 180 degrees. 90 degrees plus 90 degrees is 180 degrees. So we have 180 degrees in both sides of the equation. So 180 degrees will get cancelled and we left only with minus theta plus angle OAN is equal to 0. We added theta to this equation and we found out that the missing angle OAN equals to theta. So this angle equals to theta. And we actually found out that all the angles inside triangle AON can join to all the angles inside triangle BCQ. Therefore, those two triangles are similar to each other according to angle similarity rule. Triangle AON is similar to triangle BCQ according to angle similarity rule. I will show you again. Both triangles have angle theta. Both triangles have angle that is equal to 90 degrees minus theta, and both those two triangles have angle that is a right angle. Therefore, all the angles inside triangle AON can go into all the angles inside triangle BCQ. Therefore, those two triangles can go into each other according to angle similarity rule. And from the fact that those two triangles are similar to each other, we will conclude that CQ over AO equals to BC over ON. CQ over AO equals to BC over ON. What is the value of CQ? CQ equals to OQ minus ON. CQ equals to OQ minus CQ equals to OQ minus OC. Again, CQ equals to OQ minus OC. Okay, CQ equals to OQ minus OC, OQ equals to R, and OC equals to A according to our definition. So in conclusion, we found out that CQ equals to R minus A. So if OC equals to A, then all the other sides of square A, B, C, O will be also equal to A. And we found out that CQ equals to R minus A. So we can actually substitute CQ in this equation number 1 by R minus A. We did it and we got that CQ that is equal to R minus A over OA. OA equals to A. So OA equals to A, and it is equal to BC. BC is also equals to A. BC equals to A, and over ON. ON is equal to R. ON equals to R. So in conclusion, we found out that according to equation number 1, R minus A over A equals to A over R. We splitted equation, this expression to two expressions. R minus A over A equals to R over A minus A over A, that is minus 1. So this expression equals to R over A minus 1, that is equal to A over R, but A over R equals to 1 over R over A. And in the right triangle, triangle AON, we know that tangent theta equals to R over A. Tangent theta equals to R over A, that is to say, we can substitute R over A in this equation, equation number 1, by tangent theta. We did it and we got that according to equation number 1, tangent theta minus 1 equals to 1 over tangent theta. We substituted R over A by tangent theta. We got the tangent theta minus 1 equals to 1 over tangent theta. We multiplied the equation number 1 by tangent theta, and we got that according to equation number 1, tangent theta times tangent theta is tangent square theta, tangent theta times minus 1 is minus tangent theta, and it is equal to 1. We subtracted 1 from equation number 1, and we got the tangent square theta minus tangent theta minus 1 equals to 0. So we have here a quadratic equation, and the missing variable here is tangent theta. And the general formula for quadratic equation is ax squared plus bx plus c equals to 0. A, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X is equal to minus b plus minus square root of b squared minus 4 times ac over 2a. And in our specific quadratic equation, a, the coefficient a is equal to 1, the coefficient b is equal to minus 1, and the coefficient c is also equal to minus 1. And the missing variable, the variable that we are looking for, is tangent theta. So we put the data inside the formula for x, and we found out the value of the values of tangent theta. Tangent theta equals to minus b, b equals to minus 1. So minus b is minus 1, minus 1 is plus 1, plus minus square root of b squared. B squared is minus 1 squared, that is 1. Minus 4 times a is 1, and c is minus 1. So it is minus 4 times 1 times minus 1, that is plus 4. So inside the square root, we have, inside the root we have 4 plus 1, that is 5. So in conclusion, we found out that tangent theta equals to 1 plus minus square root of 5 over 2. So we will have two solutions that are possible for tangent theta. The first solution is tangent theta equals to 1 plus square root of 5 over 2. And the second solution for tangent theta is that tangent theta equals to 1 minus square root of 5 over 2. That is the negative solution. And here you can see that in the right triangle, triangle NMQ, we have this angle that is equal to 90 degrees minus theta. So this angle that is 90 degrees minus theta, it is one out of 3 angles inside a right triangle. Therefore, it is absolutely a positive angle. So we can write down that 90 degrees minus theta is greater than 0 from one side, but from the other side, we have here angle theta inside the right triangle BCQ, And anyway, you can see from the drawing that angle theta is a positive, so it is greater than 0. So from one side, so we have here 90 degrees minus theta greater than 0. We added theta to this equation and we got that theta is smaller than 90 degrees from one side, but from the other side we found out that theta is also greater than 0. So in this range of angles from 0 to 90 degrees, the function tangents is a positive. So if theta is between 0 to 90 degrees, then tangent theta is a positive number. But according to the second solution, tangent theta is a negative number. So we have here a contradiction, and therefore the second solution is incorrect solution. We cancel this solution, and we left only with the solution that tangent theta equals to 1 plus square root of 5 over 2. So if tangent theta equals to 1 plus square root of 5 over 2, then we will operate the opposite function of tangents, that is inverse tangents, on the result in order to get the value of theta itself. So we operated the opposite function of tangents, that is inverse tangents, on the result, that is 1 plus square root of 2 over 5, and we found out that angle theta itself equals to 58.28 degrees. So we found out the answer to the question is that the size of angle theta, this angle theta, is equal to 58.28 degrees. I repeat again, the size of this angle theta is equal to 58.28 degrees. Okay, thank you very much.